Hi everybody. This video is going to go over numbers 2 and 3, which is the penny question that the last night's video left off from, and the firefighter question that many worked on in class today. And it's intended to help you either check your answers. So for those of you that did work on numbers 2 and 3 in class today, you can check your answers. And those of us who are catching up from before, you will now have some help on finishing 2 if you needed it. And I would also ask that when I go into number 3, I will ask you to pause the video and actually finish it on your own and then check answers with me as I go from step to step. So getting back into where we left off on this well question, we had established our model that the question is asking, when does the penny reach the bottom of the well? And the bottom of the well is 100 feet below ground, which is where this negative 100 came from. H of t always comes from the question being asked. And then the initial height over here, it says that the penny leaves the man's hand at a height of 4 feet. So here he is above the well, tossing it up, and it leaves his hand at 4 feet. So that's where this initial value of 4 came from. Before I can use the quadratic formula, it has to be set equal to 0. So we added 100 over to the right-hand side of the equation, which got us 0 equals negative 16t squared plus 5t plus 104. So now that we have refreshed our memory on where this quadratic equation came from, we are ready to use our quadratic formula. And again, we should be getting these 2 answers. So let's see how this goes. I'm going to clear this up a little bit. All right. So our quadratic formula says negative b. So that will be negative 5 plus or minus the square root of b squared. So 5 squared minus 4 a c. So that will be minus 4 times negative 16 times 104, all divided by 2 times negative 16. That's 80% of the work. The other 20% is to be very careful as we go from step to step. So let's see. Negative 5 plus or minus the square root of 25. 5 times 5 is 25. And then first decide on your signs. Negative times a negative is a positive. Times a positive, that's still positive. So when I multiply these 3 numbers together, I know it'll be a positive number. Now I can use my calculator to do 4 times 16 times 104. So if you haven't gotten your calculator out yet, please do so now. Press pause, go get your calculator, and do 4 times 16 times 104. And you should be getting 6,656. All divided by negative 32. Notice I'm very clear that this division bar goes all the way across because all of that is being divided by negative 32. Negative 32 came from 2 times negative 16. Next step. Notice I'm keeping fraction, fraction, fraction. Very clear. So negative 5 plus or minus square root. I can use my calculator to do 25 plus 6,656. What do you get? Plugging that into my calculator, I get 6,681, all divided by negative 32. And now I can actually take the square root. So let's take the square root of 6,681, and we get negative 5 plus or minus 81.74, all divided by negative 32. Notice, as soon as I actually take the square root, I should not be writing the square root sign again, because I took the square root and I got this answer. I can't simplify this any farther, so now I am ready to break it up into my 2 possible answers using the plus minus. So it's going to be -5 plus, or you could write x equals -5 plus 81.74, all divided by -32. And then x equals -5 minus 81.74, all divided by -32. So we have the plus and we have the minus. Please pause and finish this up. We'll see if we match. We know from before that these are supposed to be my two answers, so I'm going to move those up. Press pause. See if you get these answers. Let's see how you did. -5 plus 81.74. Get my calculator out. Is 76.74 divided by -32. We get -2.398. And now we'll do -5 minus 81.74 and get -86.74, all divided by -32. So let's divide that by a -32. Negative divided by negative is positive, so now I get 2.71. And if you wanted to round to a third decimal place, it goes 2.7106. So that 6 makes that 0 a 1. 2.711. And we match. So if I look at these two answers, we do get the two answers that were posted at the end of the previous night's video. The question I had left you off with is, do we keep both of these answers? So looking at how we defined our variables, or what this is actually talking about, I'm sorry, I realized I didn't define the variables here, and I should have. So let's see. How long will it take? We're talking seconds, feet per second. So T is number of seconds, and F of T is height of penny. T or X, I switched over to an X, it's the same thing. So this is time. So if I were to add a label, this would be -2.398 seconds. Can we have negative time? No. Can't have negative time. So the answer, the real world answer that we will keep is 2.711 seconds until the penny hits the bottom of the well. Why do we get that negative answer? Well, if I look at what this would look like on a coordinate plane, the man is releasing the penny at a height of 4 feet. And that penny is being launched in the air, and it's falling, as it's launched, and then it's falling to the bottom of this well, which is at -100 feet. The full parabola, though, would have, if you were to graph it, right? Parabolas make that U shape. So it technically does have this side to it, but this side doesn't exist in the real world because our y-axis represents time in seconds and x is distance. Or I have that backwards. I'm sorry. Y is feet, so the distance it travels. There we go. And X is time in seconds. I can have negative distance because it's falling below the ground. So I can have positive and negatives here. But if I'm looking at my X values, we can't have negative time. So that's why this answer of negative 2.398 we have to reject, because we cannot have negative time. Moving on to the firefighter question. In giant words here at the top, it says, remember, if the model is given, use it. So let's see how that's going to work for number 3. In firefighting, powerful water hoses can shoot water dozens of feet into the air. A good water stream can be modeled by, and check it out, it gives me a model. So let me put it in a box so I don't forget that it gives it to me. Where X is the water's horizontal distance traveled in feet, and f of X is its corresponding height in feet. If a firefighter is aiming a good water stream at a building's window 25 feet above the ground, at what 2 distances can the firefighter stand from the building? Let's first define our variables. So X is water's horizontal distance in feet, and f of X is the corresponding height. So what that's really saying is, as water, let me draw you a picture to help visualize this here. If I were to put this on a graph and say that this is how the water is traveling. So as the water, I can measure the distance the water travels horizontally and vertically. So how high is the water going? So I will put it corresponding height because that's the language the question used. Also measured in feet. Realizing that we're talking the horizontal distance that the water travels for X, and then for Y, we're saying the corresponding height of the water. Vertically, how high does the water go? And it gives me this model. So let me write the model it gives me. F of X equals negative 0.003 x squared plus 0.62x plus 3. We need to remember, the key here is to remember that this comes from f of X comes from the question. So let's go read and see what the question is asking. It says, if a firefighter is aiming a good water stream at a building's window 25 feet above the ground, at what 2 distances can the firefighter stand from the building? So if I look at the 2, these are both measured in feet, so I have to be careful with what I say for where 25 goes. Is it saying 25 horizontal feet, like 25 feet away from the building? No, it's saying 25 feet above. Above is vertical distance. So I know that 25 will be a value for f of X. So I let 25 equal the rest of this model, being very careful to make sure I don't make any copy errors as I write it down. And before I can use quadratic formula, I have to remind myself that this has to be set equal to 0. So how am I going to make that happen? What needs to move for this to be set equal to 0? To get this set equal to 0, we will subtract 25 from both sides. and I get 0 equals negative 0.003 x squared plus 0.62x minus 22. Now that it's set equal to 0, I can say what's A, B, C. What's A? Well, remember that A is what's in front of x squared, so that's going to be negative 0.003. B is the middle x term, the coefficient, which is here 0.62, and then C is the constant, negative 22. Be very careful. If by accident you drop either of these negative signs as you're identifying A, B, and C, the rest of the work won't be right. That being said, if I can see what happened, like if you just dropped a negative, you'll still earn almost full credit. But I would rather we, from the get-go, not make that mistake. So from here, this is where I mentioned I'm going to challenge you to do as much of this by yourself as possible. I'm going to ask that you press pause right now and try the rest of this on your own. Recall that the quadratic formula is x equals negative b plus or minus square root of b squared minus 4ac, all divided by 2a. So press pause, start to finish on your own. When you press play, I will be going through the step-by-step solution to get to our final answer and discussing what the answers mean. Welcome back. Let's see if we match. So I'm going to say x equals, I'm going to draw a line down my equal signs to keep my work nice and neat. Negative b will be negative 0.62 plus or minus the square root of b squared. So for us, that'll be 0.62 squared minus 4. A is negative 0.003, and C is negative 22. All divided by 2a, which is negative 0.003. As crazy as that might look right now, the calculator is really going to do all of the heavy lifting for us. So we just have to be very careful from step to step that our work stays neat. And if you notice, I gave you the whole page for this question, so we have plenty of space. So it's going to be negative 0.62 plus or minus. In my calculator, I'm going to do 0.62 squared. I don't have to worry about parentheses because it's not negative. 0.62 squared gets me it says 0.3844. I'm going to round to 3 decimal places and just do 0.384. Now let's decide on our sign first. I have negative times a negative is a positive, times another negative makes this negative. Negative times a negative is positive, times a negative is minus negative. Now, I already decided my sign, so in my calculator, I can just literally type into the calculator 4 times 0.003 times 22, because I already took care of the signs. So 4 times 0.003 times 22 gets us 0.264. This is all divided by 2 times negative 0.003, which gets us negative 0.006. Again, be very careful. If you drop that negative, this will not be negative, and it's going to mess up the rest of our work. So keep track of those negative signs. Next step, negative 0.62 plus or minus. In my calculator, I can do this subtraction right here. So let's do that. 0.384 minus 0.264. And we get 0.12. all divided by, still negative 0.006. Notice how it's getting smaller from step to step, which is really nice. I can now take the square roots. So let's take the square root of 0.12, and let's see what you got. When I do that in my calculator, so this front part stays, negative 0.62. When I took the square root, I got 0.3464, and so on. I get this, 0.346410. If I'm rounding that to 3 decimal places, I'm looking at this guy right here. 4 to the right is less than 5, so it's just going to round to 0.346. And that is all divided by negative 0.006. Now I'm ready to break it up to get my two answers using my plus and minus. So negative 0.62 plus 0.346, all divided by negative 0.006. And then x equals negative 0.62 minus 0.346, all divided by negative 0.006. And let's see what you got. In my calculator, I'm typing in negative 0.62 plus 0.346. And that gets me negative 0.274, all divided by negative 0.006. I know that negative divided by negative is a positive, so in my calculator, I can just do 0.274 divided by 0.006, and I got 45.666 repeating, so I'll round that to 45.67. And then let's see what we get for our second answer. So that's 1. Negative 0.62 minus 0.346 gets me negative 0.966, all divided by negative 0.006 still. Again, negative divided by a negative is a positive, so I can just do 0.966 divided by 0.006 and get 161 exactly. So we got two positive answers. Let's go see what the question had asked. The question said, at what two distances can the firefighter stand from the building? So here are my answers. The firefighter can stand 45.67 feet or 161 feet away, and the water will reach that window. If we visualize what this means, so I'm going to put my building here. We have this window at 25 feet. So if you visualize what this means, the firefighter could stand very close, right? 40 feet is not that far. If he stands 45 feet, and he's spraying the water, it's gonna be very close. But we just calculated that that firefighter could stand at a much safer distance. This is the ground right now, right? They're standing on the ground. That firefighter can stand at a much safer distance, 161 feet away. And imagine what it looks like when water comes out of a fire hose. It's really powerful. And still reach that window. So that's what our two real-world answers mean. Very nice. I'm hoping our answers matched, and if they didn't, I hope we were able to see, was there a little bit of an algebra mistake that maybe held us up? The other part of tonight's homework is independent practice, page 32 to 33. So if those of us who needed to catch up on the full example, while this is all fresh in our brain, it would be great to get going on this and be on track with the rest of class who were able to finish most of these 2 questions in class and were maybe just using this video to check their answers. Have a great night, guys, and any questions, as always, please reach out on Remind. Bye.